Hey everyone, so here we are again to discuss another technique in integration, which is the integration by substitution. Okay, so before we start in the main topic, so let's have a review first for the basic integration rule. So first, number one, what is the integral of 5 dx? So integral of the constant, okay, integral of a dx is equivalent to ax plus c. So applying that basic integration rule, so integral of 5 dx is equivalent to 5x plus the constant c. For number 2, so the integral of the binomial x cubed plus x dx is applying the power rule. Okay, so that is x to the power of n integral, which is x to the power of n plus 1 over the denominator over n plus 1, which is this time you have the x to the power of 4 over 4 plus x squared over 2 plus c. For number 3, this is the same with the number 2. So applying that one, the integral of 3x to the power 4 plus 5x squared minus 7x dx is, you have the 3x to the power of 5 over 5 plus 5x cubed over 3 minus 7x squared over 2 plus the constant c. For the number 4, this is a transcendental and trigonometric integration. So remember, the integral of e to the power of x is equal to itself. Similarly, the derivative of e to the power of x is equal to itself. So for this one, you have the 3e to the power of x plus, okay, remember the integral of sine is negative cosine, so you have the minus cosine of x plus the constant c. C represents any constant possible. It is a positive number or a negative number. Also, it is also possible that c is 0. So another transcendental is the integral of 5 to the power of x dx. So for this one, using the transcendental basic integration, so for this one, this is 5 to the power of x over ln of 5 plus the constant c. So these examples are you can directly use the basic integration rule, okay, but not all functions is a simple functions. There are functions which are composite or consist of 2 or more functions. Okay, so what is integration by substitution? So in layman's form, this is the inverse of the chain rule in differentiation. So the proper definition for the integration by substitution is, suppose we are given an integral in the form the integral of f of g of x times the g prime of x dx. We can transform this into another form by changing the independent variable x to u. Using the substitution, u equals g times g of x. In this case, the du over dv is equivalent to g prime x dx. Therefore, from the original function, which is the integral of f of g of x times the g prime of x dx, this time this is equivalent into the integral of f of u du by substitution. So this technique is called the integration by substitution. Okay, so there are 6 steps for integration by substitution. So this is the general steps. So first, determine the u. Okay, Most of the time, okay, I'm not saying all, but most of the time, the u is the one or the function which is within the parentheses or in the denominator. Okay, again, this is not all the time. I repeat, this is only most of the time, not all. Okay, so for the second one, find, okay, if you already have your u, find the derivative of your u with respect to x. Okay, number 3, rearrange the derivative until you can make a substitution. Number 4, make the substitution to obtain the integral in u. Number 5, integrate with respect to u. And for number 6, substitute u back to the left with the expression in terms of x. Okay, so let's have an example. So for number 1, the integral of the fifth power of x plus 4 dx. Okay, so for this one, okay, we let our u, okay, which is, remember, our u is most of the time is inside the parentheses or in the denominator. So for this example, okay, it involves parentheses, therefore inside the parentheses is our u, which is equivalent to the x plus 4. The second step is find the derivative. The derivative of u is your du. The derivative of our x plus 4 is 1 dx, or this equivalent into dx. Okay, so step 3, rearrange if necessary to make a substitution. So since this one is a simple simple functions lang, it follows this is no need to rearrange. So the integral of the fifth power of x plus 4 to the power fifth power of x plus 4 dx. So we can already directly substitute, wherein our x plus 4 is equivalent into our u. Okay, so you have our x plus 4 is equivalent to our u. So for this one, you have the integral of u to the power of 5. Okay, our dx is equivalent into du. So instead of dx, you will write this one as du. So you notice the integral of u to the power 5 du can be integrated using the power rule. So for this one, this is equivalent into u to the power of 6 over 6 plus c. Okay, since our original function is not in the variable of u, so we need to substitute it back in terms of x. So you have, since u is equivalent to x plus 4, follows our original function, okay, the fifth power of x plus 4 to the power 5 dx. Okay, so it's equivalent to, okay, so our u is equivalent to x plus 4 to the power of 6 over 6 plus c. And this is now your final answer. Okay, another example. So this time, the integral of 2x times the 7th power of x squared minus 5. Okay, so what is our u? So again, think of the parentheses and the denominator. So for this one, our u, so we let u is equivalent to x squared minus 5. So the derivative of u is du. Derivative of x squared minus 5 is 2x, okay, dx. So from our original expression, so we need to rearrange this one. So we write first the x squared minus 5 to the power of 7, okay, and you have the 2x dx. Remember, since this is multiplication, okay, multiplication is commutative, therefore we can rearrange this original expression into this expression. Okay, why rearrange this one? Since we have the 2x dx is equivalent to our du, and this one is equivalent to our u. So by substitution, this is equivalent to the u to the power of 7. The 2x dx is equivalent to du. So applying power rule, so this is u to the power of 8 over 8 plus the constant c. Okay, you have, since u is equivalent to x squared minus 5, so substitute x squared minus 5 into u. So you have the integral of, you have the 2x times the x squared minus 5 to the power of 7 dx, which is our original function expression rather, is equivalent to our u here is x squared minus 5 to the power of 8 over 8 plus c. And this is now our final answer. Okay, how about if it involves, this example is integral of 4x cubed plus 3 all over x to the power 4 plus 3x minus 2 dx. Okay, so this time our u is, since there is no parentheses, therefore our u this time is the denominator, which is, you have the x to the power 4 plus 3x minus 2, and the derivative of u is the du. Derivative of x to the power 4 plus 3x minus 2 is, you have the 4x cubed plus 3 dx. Okay, so if we rearrange our original expression, we can put the dx in the numerator. So you have the integral of 4x cubed plus 3 dx all over x to the power of 4 plus 3x minus 2. Notice that the numerator is equivalent to our du. You have the integral of du, and our denominator is equivalent into u, which is this time u. And in the basic integration rule, the integral of du over u is simply equivalent to the ln of the absolute value of u plus c. And since u is equivalent to x to the power 4 plus 3x minus 2, we need to bring the variable x back. So you have the integral of the original expression 4x cubed plus 3 all over x to the power 4 plus 3x minus 2 dx is now equivalent to the ln of the absolute value of our u, which is this time you have the x to the power of 4 plus 3x minus 2 plus c. And that's all.